Systems that challenge regular standards are extending across the universe like dreamlike surfboards and interstellar pool noodles. I mean, in a real sense, it could seem like an extraterrestrial fantasy, yet it is a shocking reality. Consider the possibility that our understanding of galaxies is about to take a mind-bending leap into the extraordinary. What inconspicuous forces shape these unusual worlds? And how do they defy the standards we once believed were written in the stars? Join us on a journey beyond the ordinary as we dive into the unknown, making us rethink everything we assumed we knew about space. Are you ready to venture into the uncharted realms of our universe? Then stay with us for the rest of the video. A discovery is shaking the very foundations of our cosmic understanding. According to a study led by Viraj Panda, a NASA Hubble Fellow at Columbia University, between 50% to 80% of observed galaxies from when the universe was between 600 million to 6 billion years old were not the typical, neatly aligned structures we expected. No, they were flat and stretched out, defying our assumptions and rewriting the cosmic rulebook. It's a staggering idea, isn't it? Haowen Zhang, a co-author of the study and a PhD candidate at the University of Arizona, suggests that the James Webb Space Telescope, JWST, has provided new evidence, allowing scientists to measure the mass and potential shape of our very own galaxy billions of years ago. But the surprises don't stop there. The study reveals that these unusually shaped galaxies of the past were significantly less massive than the spirals and ellipticals we are familiar with today. Karthik Iyer, another co-author and NASA Hubble Fellow at Columbia University, emphasizes the importance of identifying these early cosmic structures, as they open new avenues for understanding the mysterious ways galaxies form and evolve. Now, with its advanced infrared imaging capabilities, JWST is capturing these distant galaxies with unprecedented detail. Its high-resolution images and sensitivity allow scientists to explore the three-dimensional shapes of these ancient cosmic structures, building upon the groundwork laid by the legendary Hubble Space Telescope. Yet there is still so much we don't know. The research team acknowledges the need for a larger sample size from JWST to refine our understanding of the properties and locations of these distant galaxies. Now, take a moment to consider the implications. What if we could witness our own Milky Way in its early days? Would it have looked more like a surfboard than the familiar spiral we recognize today? What do you think? JWST's first year of observations has been nothing short of a thrill ride, revealing countless distant galaxies dating back to the early universe. They are larger, brighter, and more evolved than astronomers ever anticipated. It seemed almost impossible that their light had traveled across the universe from around 13.3 billion years ago, less than 400 million years after the universe's birth. But then JWST stepped in, pointed its massive mirror, and confirmed these findings. The light from these galaxies is indeed ancient, dating back to just 390 million years after the Big Bang. And they are not alone. JWST has uncovered thousands of distant galaxies, each with its own story to tell. Brighter, more massive, and more mature than expected. These discoveries are rewriting the cosmic narrative. Stephen Finkelstein, an astrophysicist at the University of Texas at Austin, admits that he expected to find some galaxies at this distance, but the sheer scale of the discovery has left even seasoned astronomers in awe. For those who have been in the field for a while, this might feel like déjà vu. In the 1990s, the Hubble Space Telescope peered into what seemed like an empty patch of sky, only to reveal thousands of galaxies from when the universe was just a billion years old. These galaxies appeared mature, as if they had already undergone cosmic adolescence. That revelation fueled the quest for even earlier galaxies, ultimately leading to the launch of JWST. But that's not the only breakthrough the James Webb Space Telescope has achieved. The next mystery might intrigue you even more. Galaxies seemingly defying cosmic distance limits, with redshifts of 10, 13, and even 17. Some appear faint and small as expected, while others shine brilliantly, leaving astronomers astounded. As part of the JWST Advanced Deep Extragalactic Survey, JADES, scientists set out to confirm the distances of galaxies with photometric redshifts higher than 10, a potential gateway to the epoch of reionization. And then a cosmic surprise. A galaxy now known as JADES GSZ 11.0 claims the title of the most distant ever confirmed, with a redshift of 11.58. Another, with a redshift of 13.2, hails from a time just 325 million years after the Big Bang. The spectral data analyzed by the team provides insight into the properties of these galaxies. These cosmic entities, merely 1/100th the size and mass of the Milky Way, baffle astronomers with their rapid star formation rates. In this grand cosmic drama, newborn stars emit ionizing radiation, suggesting that these galaxies might be among the earliest architects of reionization. Yet, the JWST has also delivered a reality check. The Cosmic Evolution Early Release Science (SEERS) survey initially identified a galaxy, SUS 93316, with a redshift of 16.4, a potential record breaker. However, once the spectral data was analyzed, the redshift dropped to 4.9, a reminder that the cosmic stage is full of surprises. Finkelstein, the lead researcher of the SEERS survey, acknowledges the occasional discrepancy, calling it an anomalous case rather than a major setback. This discovery eases the burden on JWST's observation strategy, allowing astronomers to trust the validity of most redshift measurements while reserving detailed spectroscopic analysis for truly extraordinary cosmic objects. As a result, JWST has unveiled yet another celestial surprise, an unexpected twist in the story of galaxy formation. But it appears that there are far more bright galaxies at redshift 10 than astronomers had predicted. What does a galaxy's brightness truly signify? It's a massive clue, a luminous signal indicating the mass of the galaxy and, in turn, the abundance of stars within it. The brighter the galaxy, the more stars it harbors, illuminating the universe with their brilliance. Armed with simulations and theoretical models, astronomers had a reasonable estimate of the number and size of dark matter halos that formed the first galaxies. They envisioned the grand assembly of galaxies, fueled by hydrogen and helium, the cosmic clay from which stars are born. The theoretical upper limit for a galaxy's size, if it consumed all available gas, hovers around 10 billion times the mass of our Sun. Yet, JWST has not yet found any galaxy near this theoretical limit. Instead, it has stumbled upon an overwhelming abundance of robust, early galaxies, far more massive than expected. JADE's galaxies are tipping the scales at around 100 million Sun-based masses only 330 million years post-enormous detonation, and SCUS worlds flaunting over a billion suns worth of stars a mere 450 million years into the astronomical narrative, test the constraints of fast matter gathering in the astronomical spring between the huge explosion and the astronomical now. Cosmologist Caitlin Casey recommends that maybe a portion of the heavenly brilliance doesn't rise up out of stars straightforwardly. Might it be that the light is a divine dance coordinated by ionized gas settled between stars in the throes of development? If so, these universes might not be as massive as their radiance suggests. Now, this is truly astounding and most definitely out of the box. As stargazer Robertson carefully puts it, unraveling the secrets of early systems is the key to understanding the origins of our infinite home. This is where the story starts, at redshift 10, the beginning of our infinite presence. Let me present the universe breakers, a set of systems that not only defy the standards of galaxy formation but also challenge the very theoretical foundations of our universe. 6 heavenly peculiarities, spotted with burns, have grown to such giant extents in the mere blink of astronomical time that they've earned this captivating moniker from cosmologist Nelson, the universe breakers. With photometric redshifts ranging between S and N, these cosmic giants emerged within the first 800 million years, boasting stellar masses rivaling or surpassing our Milky Way at a staggering 60 billion solar masses. Mike Ben-Elon, an astrophysicist from the University of Texas at Austin, throws an astronomical spanner into the works. The conventional matter available at that time, the cosmic atoms at the disposal of these young galaxies, would have had to convert entirely into stars to birth these universe breakers. It's a daunting challenge, and as Baku Lin succinctly puts it, it's exceptionally difficult to accommodate them within our current models. Dark energy, the elusive force propelling the universe's expansion, emerges as a potential hero in this grand cosmic drama. By injecting a portion of early dark energy, theorists speculate we might observe larger reservoirs of particles and faster cosmic growth. Could these universe breakers be the result of supercompact early galaxies efficiently converting all their gas into stars before the oldest stars met their explosive finale in supernovae, scattering star stuff? Astrophysicist Avis H. and colleagues propose this alternative, a grand explanation that doesn't break the universe but merely bends its rules. A spectral analysis of one of these objects reveals not a universe breaker, after all, but rather a galaxy at redshift 5.6, with a ravenous black hole contributing to its brilliance in the cosmic spectacle. The astronomical drama continues, and the answers might rewrite the very rules of our cosmic narrative. The breadstick galaxies. Approximately 50% to 80% of the galaxies studied appeared flattened in 2 dimensions, resembling long, thin breadsticks. The unexpected twist. These breadstick-shaped galaxies were more common in the early universe, a striking departure from the round galaxies typical of our modern-day universe. Erica P., a NASA Hubble Fellow at Columbia University and lead author of the study, opens the door to this cosmic mystery. She hypothesizes that the answer may lie in the cosmic highways formed by filaments of dark matter. These filaments, like a skeletal framework, might have guided gas and stars, shaping galaxies into the extraordinary breadstick structures observed in telescope images. Using the James Webb Space Telescope's Cosmic Evolution Early Release Science Survey, researchers sifted through a vast field of near-infrared images. The galaxies selected for investigation are estimated to have existed between 600 million and 6 billion years after the Big Bang. The findings are captivating. Galaxies resembling pizza pies and blobs of pizza dough also appear. But what about our own Milky Way? If we could go back in time by billions of years, would it have looked like a breadstick, a pizza pie, or something else? Haowen Zhang, a PhD candidate at the University of Arizona, proposes a theory. Our Milky Way may have resembled a breadstick in its early days. This idea stems from estimates of the Milky Way's mass billions of years ago, revealing a possible connection to the elongated galaxies seen in the early universe. The cosmic mystery deepens. Recent data from JWST is challenging the very fabric of our understanding. A freshly published paper reveals a mind-bending revelation. Objects older than the universe itself have been spotted. Yes, you read that right, galaxies that predate our known universe. This cosmic enigma has scientists scratching their heads. While researchers remain cautious, awaiting peer review to confirm these astonishing discoveries, let's dive into what we know so far. The JWST has shattered records, surpassing even the Hubble Space Telescope's groundbreaking discoveries. The most distant galaxy ever observed, JWST, existed a mere 300 million years after the Big Bang, placing it at an astonishing 33 billion light-years from Earth, thanks to the universe's expansion. Among these distant galaxies, one turned out to be a false alarm, a dust cloud playing cosmic hide-and-seek, tricking our observations and challenging the very instruments we use to decipher the universe. But JWST may have witnessed galaxies even closer to the Big Bang. Galaxies that throw our established cosmological models into disarray. And just when you thought the roller coaster was slowing down, JWST unveiled another surprise. Our current model predicted a specific pattern for the formation of early galaxies. As we peer further into the past, galaxies should become less structured and smaller. But guess what? Recent observations reveal the opposite. Some early galaxies appear larger and more organized than expected. Cosmic giants and the unexpected reality. Enter the cosmic monsters. Galaxies like JWST, eerily resembling our Milky Way, yet emerging only a few million years after the Big Bang. This defies the expected timeline for the formation of spiral galaxies, shaking our understanding of cosmic evolution. Right after the Big Bang, when the universe was in its infancy, only 500 to 700 million years old, expectations were clear. We anticipated the birth of young, small galaxies, emerging like cosmic newborns from the dark ages. The first stars were supposed to be like eager toddlers, glowing bright blue with youthful energy. But the images captured by JWST during its early observation campaign revealed a cosmic anomaly. Giant, mature galaxies robust enough to rival our own Milky Way appearing as tiny reddish dots in the telescope's field of view. It's like discovering a grizzled elder in a nursery full of babies. Nobody saw this coming. These massive, ancient galaxies, filled with mature red stars, defy the expected narrative of the early universe. Joel Leha, an assistant professor of astronomy at Penn State, raises an eyebrow at this celestial puzzle. He remarks, "We had specific expectations for young and small galaxies in the early universe. They are supposed to be young and small. This is perplexing. We're finding galaxy candidates as massive as our own Milky Way when the universe was only 3% of its current age." The Hubble Space Telescope, JWST's predecessor, painted a different picture. Past observations suggested a universe teeming with tiny blue baby galaxies in its infancy. But now we are faced with the stark contrast of mature cosmic behemoths. One thing is certain: the cosmic timeline is far more tangled than we ever imagined.